friends, actually we are coming into the last part of the series of videos on closed loop PID controller design using machine learning. As you can see on the screen at the top, we have just created a temperature controller, complete temperature controller in closed loop. The results can be seen, in red. Actually it is stabilizing the set point, which is in black. Now how do you achieve this? Many of the videos which we have already gone through will be very useful for you to understand this final two videos, and also all the programs will be given at the end of this video, and also you may continuously take a look at all the previous videos before you understand each and everything in this. So as you can see on the screen, there is a set point TSP and there is an error temperature T1 is coming. As you can see on the screen, the temperature comes to a stabilized temperature when we apply PID algorithm. Now PID algorithm is applied through LSTM. See, this is the hardware setup of this, and there will be another video after this which will give details of how this controller can be designed. However, you can see that whatever the temperature you are reading, 16.1 degrees, from a thermocouple sensor. This is a simple meter which displays that. It gives a 0 to 10 volt input to this controller. So this 16.1 comes here is 15.8. It's almost close. Let's assume that this is also 16. Then there will be a power which is going into the heater. This heater, that is a QI, which is in 0 to 100%. This will be 0 to 100 degrees. So the objective of this setup, that is hardware device and a Python program, is to implement a complete temperature controller using artificial intelligence method, and it uses LSTM for real-time temperature controller, and it's like univariate data coming into the LSTM. So now the theory is actually to integrate the LSTM neural network. This is a type of recurrent neural network which we discussed in the previous videos. This is to learn and predict the appropriate heater output, of the temperature control. And LSTM model takes the set point temperature TSP and the error between the set point and the actual temperature as the input features to generate the heater output. The training data for the LSTM model is obtained from the earlier videos, that is an H5 file, which is a standalone model which you have created, which also has a CSV file, that is a dataset that you can see in the previous videos. Now the procedure for the program is going to be in the forthcoming slides. Now if you look at the necessary files, actually you can see that there are some libraries which are required to be imported, and you can stop the video and see it later. Many of the things actually in this program, so you can see the entire program is here. The entire program will be divided into two sections. One is actually to read the temperature from the device on the left hand side, and the right hand side the GUI, to design the GUI to bring the output, visualize the output. So left side will be the data reading and the LSTM functions, and right side will be the GUI. Now many of the things, this is not that readable, but it will be at the end of the description. But at the same time, remember that you have to stop your video and carefully watch later, because I won't be able to cover all the points except you read it later, and this is a very, very important topic. So first thing is actually load a pre-trained LSTM model which we created in last video, that is an H5 file which contains a PI controller, dataset, or model, sorry, H5 is a model and CSV is the data set of that. And this is the single line new model, just load in one single line can load the data into a model, and new model, and new data frame that is actually coming from the CSV file. And as I explained earlier, the CSV file looks like this, a lot of columns, and we just got Q1, T1, TSP, ERR, error, etc. And you need to scale the data. That is what the next lines are actually all about. You see, you have to scale the data to appropriate significant values. So the relevant features are extracted from the loaded CSV and they are scaled using min-max scaler, which is scikit-learn library, and which was discussed in the previous videos also. Now there is a window size involved in any LSTM model. Window size, it can be explained here is if you have a series of data or sequence of data coming in serially, one after another, time-stamped one, you divide it into several rows and 2 columns. So rows like 10, 20, 30, then 40 will be output, 20, 30, 40, 50 will be the output. So you make multiple sequences of window size 3 in this particular case. In our case, it is going to be window size 15. Now you have to read the temperature from the device. It's not that the device is a HTTP server. Simply you can connect it to your LAN port and read the temperature from the thermocouple sensor. You see one single GET request. So this particular thing you can see in a browser. If you type 192.168.1.102, this is the device address //RPC port1.read. This is a pre-coded command. Actually, when you do this, it will return the temperature 0.201. You have to multiply by 100 to get the exact temperature. That is what this function does. So indirectly, instead of executing this command, get command on a browser, you are reading through a Python program. Now, sometimes you may have to read 10 times a data every second and average it out if you have a lot of noise. But in our case, it's reading it's clean data, so every second we are reading that. Now, there is another function called write DAC. Is nothing but digital to analog converter accepts 0 to 10 volt. You have to write these values so that you can heat the heater. 5 means 50%, 10 means 100% power. It will go into it's a DC voltage, it's going to the DC heater, small heater. This is a function for that. This has also been discussed in the earlier videos. So command you are passing is http://192.168.1.102. This is the command 0.5. Write 0.5 means 50% of the power. Nothing but 5 volt you are writing. So now, to execute any HTTP command actually from Python, you need, or from anywhere, you need to do an execution of a get command. That's what it is. And LSTM controller function, it implements a control logic using the LSTM model to read current temperature samples and set point sample. Now you have to read the current temperature every second, returns Q in real time. So that is what is the aim. Now you are going to read the temperature. You set a set point and read the temperature every second for longer time, continuously, infinite time you can say, so that you will see how the output is going to come. So that is what actually we are going to discuss. Now the LSTM model is then used to predict the heater output. This is the main function, the core of the function. You pass your set point and your current temperature, T1M current temperature, TSP is the set point, and the function will return the power. That's all. That simple it is. This is the core of the program. Now how to create a UI to read temperature and see how the profile is going to look like. So you have two methods of doing it. One is in auto mode, other is manual mode in PID. In manual mode means you just give a fixed power and just to see whether system is working. Like 50% of the power you give and try to see. It's like unit step function you give. You can test the system. Otherwise, auto mode means is completely PID will take care. See, this is right now you can see that it's completely in PID in auto mode operation. This is the red one is the temperature being read back and stabilized, and the black one or blue one actually I think it is somewhat black. That is set point, and green one is the power which is being automatically handled with the PID LSTM function. See, you can see on the left hand side the set point was 40, and you can initially give a power if you want actually, and after that the moment you put into the LSTM auto, it will override everything, and it starts working automatically giving Q values, and you can see that Q values will be changing. And see, we have got a reasonably good LSTM output with a very small steady state error. So the most important thing, you have to create a GUI. It's a TK-Ender is used for this. So to use TK-Ender, this is import TK-Ender as TK. This is how you call it. And all these screens you can stop and watch later slowly, but I will be going very fast. Now in order to do the TK-Ender GUI, you can simply root is equal to tk.tk. You can do like this, and this kind of a screen you are trying to now create. You have to create different labels like set point. There is a label, and you have also created. You have to you have to create more and more labels. So how do you do that? So you have created an update button here. You can see that there is an update button. That means, if you want to change the TSP, set point in between, you can give new value 50 or something and press this button. Then you have to manually, suppose you want to test, give a step input manually to it and see how the profile is going. You have to take it to the manual mode here, or manual override it is called. One more time and another time, if you press on this, it will come, whichever comes green, that is what it is working on. This is a manual mode. Otherwise you can take it to, click on this, it will become green, then it will go auto mode. So now the manual label can be created. You can see that manual value, this is what is created here, and these are the different outputs. Now you can see that actually the manual override, etc., LSTM auto, etc., can be seen here. How do you create all these labels? They are simple GUI programming. And after all this, now you have to start reading the current values into the label set. So for that, actually this is what is this label. Label is, you can see that TK label root, this one y is equal to this. That means the current value will be updated into the label. So that is what it says. Labels are created to display the current values of various parameters including LSTM control output, etc. You simply call the values from the earlier functions. Now the visualization to get like this, you have to simply define a XY screen, and for the real time visualization and real time plot. So now you can modify a simulation program using TCLab. Is a library which is used actually to implement an LSTM based controller, where the simulation library, that means exactly like the soft PID, so that these functions are available in TCLab. This is utilized to create this. Now the main thing is, now you have to create a variable called runtime, which is, suppose it is for 24 hours you are going to display in the x-axis, then 24 multiplied by 6 minutes, that is 1444 rows in the time axis will be reserved for this. Now, in seconds it will be 86,400 seconds, that will be in the x-axis, and you simply initialize with the zeros T1, QLS. These are three different parameters which are going to be displayed here. One is SP, T1 and QLSTM. They are initially initialized 0. Then set point, temperature set point initialization is initialized as an array with constant values equal to the initial temperature of the TC lab. See that this is how you start the TC lab, the library. So you can read lab.t1 is nothing but the temperature, real time temperature each second. Now you can have certain flags actually to make it green and different values to put this, etc, etc. So where you want to know whether it is in manual mode or auto mode, some basic things are there. Then the main loop starts. You are going to now start the loop actually every second. It is going to run every second. It is going to take the temperature value, write into an array, and TA value, etc, etc. And then it calculates the QLSTM, that is also going into the predicted output is coming into the the so-called LSTMI. Now this is the predicted value. Now control logic for all this is basically, you can see that the current values and control logic are updated based on the selected mode. You can write power into the system using write DAC. Then you can update the valve, text box actually, nothing but the button for manual mode or automatic mode. So if it is if it is not manual, this is automatically going on taking QLSTMI and putting into the writing into the heater, and also the outputs are appended to the QLSTM values, etc. Now how to visualize the temperature, real-time temperature set point and heater values, they are here. Now you are going to plot it. The plotting is nothing but you have to create an XY frame. That is where you have created a label called time, and this kind of a screen you are going to get it. And it gets every second, it gets updated to the screen. These three values, SP, T1 and QLST. So now the additional, this is additional lines are nothing but some labels you have created for the title, etc, etc. Now you can also save the data whatever is on your screen into every 1 hour it will come on the screen. After that you will create a fresh screen. You can simply write into a CSV file also to see how it has come. So overall TK GUI is what you have created using the LSTM functions from behind. So you have created a temperature controller. You can look for one more video on how the device is created, LSTM controller device. That will be in the next video. That will be the end of the series. Thank you.